All right, so let's talk about transactions and JDBC. So up to this point, we've been using the simplest of transaction handling, which is basically the autocommit behavior that JDBC uses out of the box. Right? If you don't say anything, if you don't configure any isolation level, it uses autocommit. Right? So we're going to take a look at how is that we can reconfigure JDBC so that we can explicitly demarcate transactions ourselves. All right? So this is these concepts are the same regardless of what library you end up using. We're going to look at JDBC, but any other library that handles database connections will have some mechanisms for you to establish some the level of isolation that you want to establish. Okay. Also, different vendors will have different default isolation levels. Right? So you should read the documentation for the particular vendor, database vendor, of what their default isolation level is. Here we're going to look at the JDBC and its default behavior. So the as mentioned earlier, the default behavior is that it uses autocommit, right? So that every time you do an operation from JDBC, either with a prepared statement or just a just plain old statement, you know, whether you do a select or an insert or an update or delete, it self commits. Right at the end of the operation, it immediately commits after that, and that's certainly not ideal if you need to make up multiple operations that need to be considered as a single unit of operation. If it's just you know, if your application is the only one accessing the database, then there is no concurrency issue, right? You don't have multiple threads or multiple processes accessing the same database, so you don't really need anything more than just autocommit, right? But if you have multiple threads or you have different processes accessing your database, if you have anything that is you know, big enough to be anything serious, you would have to have multiple threads and multiple processes accessing your database. So here's an example where autocommit might fail, where you have two statements that are both operating on the same piece of data. Right? You have two statements, statements 1 and statement 2. The first statement queries and it comes back with some result set, right? And then we start iterating over that result set. If you remember, that result set is a live connection on the database, right? We only retrieve as many rows as we can cache, right? And then we go and fetch some more, right? So that first result set is calculated, and the records that meet that criteria are defined and said, okay, well, these are the rows that met your criteria. I'm only going to fetch a few of them at a time, not all of them. Meanwhile, we have a second statement that what's going to do is that as it iterates in the outer loop in the result set, it's going to try and remove records, you know, depending on some criteria, which kind of messes up the original outer loop, right? Because they're both operating on the same data set and the same rows you know, that one wants to iterate over and the other wants to operate over, right? So this one is we have the outer while here is iterating over the outer result set. Meanwhile, inside we're going to use the second statement to update the list, the result set. Right, so here's we grab the title from the outer result set, and we make a decision whether this course was great or not. Based on that result, whether, you know, depending on the feedback of students, if it's not a good course, we're going to grab the ID of the course, and we're just going to remove the course. Right here, we're going to delete from the course where the CID is CID. Notice that this affects the outer loop, right? Because the outer loop assumes that you have, you know, maybe 20 courses, right? Whereas the inner one might be removing a few, right? That at the end of the day, you'll end up with maybe, you know, only 15 courses, which is affecting the outer loop. Right? So this would give some weird results. Because as the outer one is iterating, it might not find those records that it was expecting in the outer loop, right? So there's a classical example. Even though this is not a multi-threaded, you have two queries that are depending on the same data. So basically you have here two transactions. You have an outer transaction that is dealing with some data and has not yet committed, right? Has not yet decided what to do of any changes. Whereas you have an inner one that is committing every time it deletes, right? It deletes and it makes the changes permanent. Deletes and makes the changes permanent. But the outer one has not yet committed, has not yet completed, right? So this is a classical example of two transactions overlapping each other, right? As opposed to serializing it the way it should be. So yeah, autocommit is not enough. We're looking at the original example of swapping two professors. You might be one transaction is updating the number of sections that a particular professor is enrolled in, and it wants to decrement those sections as it swaps them between the different sections. Meanwhile, a different transaction might be calculating the number of sections. So the first one, we might be having multiple commands here, multiple statements, where one of them is updating the section, the professor for one section and the profession for some other section. Brando for section 43 and Einstein for section 53, and all being done with different commands, command 1 and command 2. But notice what happens if only one of them is successful. I was able to enroll Brando, but I was not able to enroll Einstein, right? I wasn't able to swap them. Maybe the server crashed or something went wrong. But meanwhile, a different operation might be calculating the number of sections that you're enrolled and calculating your bonuses, right? It might be coming back with a wrong computation. So to fix this, we're going to need to explicitly demarcate the transactions. And the way we do this is that we're going to turn off the autocommit. We're going to say we don't want autocommit. Instead of you implicitly deciding when to commit, I want to explicitly decide when to commit. I want to decide it. And the way we do that is that it's through the connection object that you get from the database. The connection object has some API that allows you to handle the transactions, allow you to turn off autocommit, and then to explicitly commit or explicitly roll back. Okay? Right, so once we have the connection, right, we can turn off autocommit. We're going to say set autocommit to false, and then do several operations, insert, updates, deletes, and whatnot. Right, and then we can explicitly decide to commit, or if there's some error, some exception is thrown, or some miscommunication, we can catch that and decide to roll back any of the changes that happen in here. Right, we never made permanent. We never made it permanent. If anything happens here, we have like 10 operations to do, and on the 5th operation we get an exception. Right, we're gonna jump into the exception handler here, and we're just gonna roll back, meaning all those 5 operations that were successful, I'm gonna throw them away as if they never happened. Go back to my previous state, consistent state. Right. So here's another example. Right, we set autocommit to false. And then we do several operations of deleting courses and whatnot, and then doing the commit at the end. Okay, so these are our same examples that we looked at earlier on how to calculate 100,000 divided the number of students, and then we make the commit, making sure that the update we had isolated ourselves from other transactions that might be operating on the same data. Also, the connection object allows you to set the isolation levels, to different ones. So for instance, you can set it to read committed, read uncommitted, read repeatable read, and serializable. The same connection object has a method that allows you to set that. It's called the connection.setTransactionIsolation, and you can pass in a constant value to the different transaction level that you want. The default is read committed. That's the default. So if you don't say anything, at least you won't be doing some dirty reads, right? Because the default one forces you to read only committed data, right? So at least you have that, but you still be vulnerable to repeatable reads and phantom reads, right? So if you want to fix everything, right, that you don't want you want repeatable reads, that you don't want phantom reads, then you can set it to transaction serializable, and this fixes all the inconsistency risks are gone, right, by setting the highest level of serialization. Okay.